Welcome back. In this section, we'll examine the symbols and notation used in a typical PLC ladder logic diagram. The first point we should notice is that references such as PB1, PB2 and M1 have been replaced by a letter-number combination which represents the I/O address of each external device connected to the PLC. These addresses correspond to specific locations on the I/O housing where the external devices are wired. Now, if we think of the block sorting machine as a collection of input and output devices, it will help us understand the importance of having specific addresses for each input and output device connected to the PLC. The assignment of input and output devices and their address locations is shown here. Notice that the address location defines the exact I/O connection point, and no two I/O address locations can have the same identity, since under PLC control, any input can be arranged to switch any output without physically changing the wiring. Although our PLC uses X and Y symbols to identify its input and output points, other PLC manufacturers may use numbers to define the I/O address locations. Now, suppose we wanted to make this limit switch turn on this indicator lamp. We could wire it directly to the lamp, but let's imagine that we had a way to connect that limit switch to the lamp without actually rewiring it. All that is required is to select the devices and then place them in the correct position on the ladder logic diagram. In fact, a PLC-managed system allows us to select any number of inputs and combine them in series or parallel to activate any combination of outputs. All we have to do is to create the necessary logic by selecting the appropriate input and output devices. This is a key principle on which the operation of a programmable controller is based. Think of it like this. When we program a PLC, it is like wiring a relay control panel, except that no physical wiring is necessary. All the connections are made by using a programming device to enter the ladder logic diagram into the PLC. The controller is able to utilize any I/O device in any order, anywhere in the circuit where they're required. And the PLC can use the same device at many different places in the logic to accommodate different system requirements, because each input and output has its own unique address location. This is where we find the big differences between PLC and relay logic control systems. Although programming styles do vary amongst the various PLC manufacturers, there are two important points that all PLC logic has in common. Firstly, input devices are entered into the ladder diagram as contacts, and output devices as coils. And secondly, PLC ladder logic diagrams require that the address locations for the input and output devices be specified whenever those devices are called for in the logic. Our PLC requires that input addresses are specified by the letter X, followed by the number of the input channel, and output addresses with the letter Y, followed by the number of the output channel. So, we have connected the external devices from our sorting machine to the following I/O locations. The start switch is connected to X0, the stop switch to X1, the upper limit switch to X2, and the lower limit switch to X3. The output devices will also need to be assigned addresses, so we have specified the output addresses as follows. The conveyor motor is wired to Y0. the run lamp to Y1, the solenoid valve to Y2, the alarm buzzer to Y3, and the stop lamp to Y4. Now you might appreciate why, when maintaining or tracing faults in a PLC-managed system, it is imperative to know what each external device is, where it is located, and how it is connected, which is why the use of relay symbolism is such an important part of the system documentation. But as far as the PLC is concerned, it does not need to know what type of input or output device is being used, only the address location of each device and what must be done with the on-off signals appearing at the input points. After the break, we'll explain how the PLC processes the on-off signals arriving at its inputs.